If you want to be a hacker, you have to learn networking. That's simple. You can learn all the tools you want, but if you don't understand how data moves from point A to point B, you're just clicking buttons without knowing why. Networking is a language computers use to talk. If you don't speak the language, you simply can't join the conversation. But here's the thing. Networking is huge. You could spend years studying it and still feel lost, which is something that I did. So how do you know what parts actually matter for a hacker and what parts are a waste of time? In this video, I'm going to show you exactly what you need to learn to start hacking. Before we dive in, if you're new here, I'm Aryan, and in this channel, I'm going to teach you everything you need to become a great security engineer. So, what is networking? Basically, it's just how computers talk to each other, whether it's two laptops in the same room or a server on the other side of the planet. They need a system to send and receive data. As a hacker, you need to understand this because you can't find a weakness in the system if you don't know how the data is moving. But here's the secret. You don't need to know everything. Depending on your goal, like web hacking or network pen testing, you might need to go deeper in some areas and just know the basics in the others. To keep things organized, we use two main models, the TCP/IP stack and the OSI model. Now, to be honest, the real world mostly uses TCP/IP, but the OSI model is so much better for learning. It breaks down everything into 7 layers. Think of it like a sandwich. Each layer adds a specific piece of information to your data. When you send a message, it gets wrapped in packets that travel through different hardware until they reach the destination. In this video, I'm not going to teach you every tiny details. Instead, I'm giving you a roadmap. And I'm going to go through these layers one by one, tell you exactly what topics you should study, and show you some examples of the tools and attacks used at each stage. This way, you can learn on your own or wait for the full course I'm building for the future. So let's start at the very bottom. Most people think hacking only happens through a screen. But sometimes the hack starts with a physical cable or a radio wave. If you can touch the hardware, you can own the network. So let's look at layer 1, the physical layer. Like the name says, this is about actual hardware, the cables and the radio waves, and the electricity moving through them. It's the foundation of the entire model. At this level, we aren't talking about files or emails yet. We are talking about bits, just ones and zeros, traveling through things like Ethernet cables or fiber optics. You'll hear about hardwares like hubs and repeaters. A hub is a dumb device. If it receives the data, it just repeats it and sends it to everyone connected to it. It doesn't know who the data is for, it just screams out it to the whole world. So in technical terms, it broadcasts the data. Now, why does a hacker care about a cable or a radio wave? Because if you have physical access, you have a huge advantage. For example, hackers use things like a Wi-Fi pineapple. It's a rogue access point that looks like a normal Wi-Fi network, but when you connect to it, the hacker sees everything you do. But what happens once the data leaves the cable and enters the machine? How does the network know exactly which laptop should get the data without screaming to everyone? So to solve that, we have to move up one level to the layer where every device has its own unique ID. So let's look at the layer 2, the data link layer. Every single network card in the world has a unique name called a MAC address. While an IP address can change, the MAC address is usually burned into the hardware. And at this layer, we use switches. Remember how I said hubs were dumb? Well, switches are smart. They keep a list of every MAC address connected to them, so they only send data to the person who is supposed to get it. You also need to learn about ARP. This is a protocol that acts like a translator. It helps the network to find out which MAC address belongs to which IP address. But here's where the fun starts for hackers. Protocols like ARP are very trusting. They don't usually double check if someone is lying. So hackers use a technique called ARP spoofing. Using tools like Bettercap, you can basically shout to the network, "Hey, I'm the router," and tell the router, "Hey, I am the victim." Because the devices believe you, all the data flows through your computer first. You're now the man in the middle. You can see their passwords, their messages, and everything they do online. Layer 2 is great for attacking people in the same room as you. But what if you want to reach your server on the other side of the planet? Well, MAC addresses can't help you there. For that, we need a global system, a way to route data through thousands of different networks until it finds the target. So let's move up to the layer that runs the entire internet, which is layer 3, the network layer. This is the layer that makes the internet work. While layer 2 finds a neighbor, layer 2 finds anyone in the world. The most important thing here is the IP address. Think of it like a digital home address. You have IPv4, which are the numbers you're used to, like 192.168.1.1, and IPv6, which are the newer, longer addresses. To manage all these addresses, we use routers. These are like the traffic controllers on the internet. They use a process called routing to look at the packet and decide the best path for it to reach its destination. You also have firewalls here, which act like security guards. They can give a packet to see if it's allowed to pass or if it looks dangerous. Another big concept here is NAT. This is how your whole family can use one internet connection at home, but each of them has their own devices. If I want to hack a company, I start at layer 3. I use a tool called Nmap to scan their IP addresses. It basically tells me, is this server live? Is that computer online? And I also use traceroute. This tool shows me every single hop or router my data touches before it hits the target. Now, once a hacker finds a live IP address, they have a new problem. Just because I found a building doesn't mean I'm inside. A single server can do 1,000 different things. It can host a website, send emails, or store files. So how do we know which door to knock on? And how do we make sure our data stays in the right order? For that, we have to go to layer 4, the transport layer. This is where we decide how we want to send our data and which door to knock on. In networking, those doors are called ports. Every computer has about 65,000 of them. For example, port 80 is used for website and port 22 is for remote access using SSH protocol. At this layer, you have to choose between two main protocols, TCP and UDP. Well, TCP is the polite way to talk. It uses something called a three-way handshake. It's like saying, hello, can I talk to you? And they say, yes, I'm listening. And finally you say, great, here's your data. It makes sure that everything arrives in the right order and nothing is lost. On the other hand, we have UDP, which is the chaotic way. It doesn't care about handshakes. It just throws data at the target as fast as possible. So if some data gets lost, we don't care. This is what we use for things like video calls or online gaming, where speed is more important than being perfect. For a hacker, layer 4 is all about finding open doors. We use port scanning with tools like Nmap to see which of those 65,000 doors are unlocked. And if we find an open port, we might use another tool called Netcat, which we call the Swiss Army knife of the hackers, to send raw data directly into the door or even create a shell to take control of the system. Alright, so now you found an open door and you started a conversation. But what if that conversation is encrypted? Or what if the data is written in the code that you don't understand? To actually read the secrets inside, we need to look at how the data is formatted and kept private. So let's move up to layer 5 and 6, session and presentation. Layers 5 and 6 are session and presentation layers. I'm putting them together because they both deal with how your data looks and how long the chat lasts. Layer 5 or session layer is like the manager of the conversation. It makes sure that when you log into the website, the server remembers who you are so you don't have to put in your password every time you click a new page. And layer 6 or presentation layer is a translator. It handles things like encoding, which is changing data into formats like base64 or hex, and most importantly, encryption. This is where SSL and TLS lives, the stuff that puts a lock icon in your browser and keeps your credit card number private. So why do hackers care about this? First, there's session hijacking. If a hacker can steal your session cookie, they can trick the server into thinking they are you. They don't even need your password. They just jump into your active session. And second, hackers use tools like CyberChef to decode data. Sometimes developers try to hide secrets by encoding them in base64, thinking it's secure. A hacker sees that and decodes it in seconds. So, we've gone from physical cables all the way up to encryption. We are almost at the top. But where do you actually spend most of your time? You spend it on websites, apps, and APIs. This is the top floor of the building, and it's where most modern hacking happens today. So let's finish this with layer 7, the application layer. Now finally, we are at the top, the application layer. This is the layer you actually see when you open Chrome, send an email, or use an app on your phone. The most important protocol here is HTTP or HTTPS, which is HTTP on SSL and TLS that we talked about in previous layer. It's basically how web browsers talk to servers. You also have DNS, which is the phone book of the internet. It turns a name like google.com into an IP address that your computer can actually understand. In the real world, big websites use things like proxies and CDNs like Cloudflare to stay fast and safe. They sit in front of the actual server to filter traffic. Use a tool called Burp Suite to catch the data leaving your browser before it hits the internet. This lets us change the data, like changing the price from $100 to $1 to see if the website is coded correctly. We also use tools like fluff or dir search to look for hidden files or folders that owner forgot to lock. And for the advanced hackers, this is where we do things like HTTP request smuggling. This is a way to confuse those proxies and mailboxes I mentioned earlier, which is a bit more advanced, but it shows that this layer matters. Alright, that was a lot of information. But like I said at the start, you don't need to be a network engineer on day one. You just need to know what to focus on. So if you're serious about this, here's your list. These are the concepts you need to go and research right now, and you can do it in the order that we talked about in the video. First, the basics. Understand the OSI model versus TCP IP. Learn concepts of MAC address, R protocol, and IP addresses. Then you need to be 100% comfortable with ports and the difference between TCP and UDP. Next, learn how the web actually moves. Study DNS, HTTP, and how SSL TLS keeps things private. You should also know the difference between the hardware, routers, hubs, and switches. Now you can go through more advanced topics like NAT and port forwarding, CDNs, proxies, and how firewalls actually block traffic. Understanding how the front end talks to backend through all those middle boxes is what separates a beginner from a professional researcher. And I know this feels a lot to learn on your own. To make it easier for you, I've put together a high quality roadmap and some infographics that break down everything we talked about today. So in order to get them for free, just click the link in the description and I will email them to you. And if you found the roadmap helpful, hit the like button and subscribe. It really helps the channel, and I've got a lot more technical deep dives coming your way very soon. Thanks for watching. See you in the next one.